Hi everyone. We are doing this lab for CMPE285 for fall 22 semester at San Jose State. This is a tryout video for YouTube, and we are choosing the topic of design patterns to discuss here. The teammates are Sayali, Saurabh, Brinda, and Meena. Next slide, please. Okay, so design patterns. What are they? Design patterns are typical solutions to common problems in software design. Each pattern is like a blueprint that you can customize to solve a particular design problems. And these problems are very common problems in software designs, and these are the solutions for them. They define a common language that helps your team communicate more efficiently just through your code. It makes your code clean and efficient. Next slide, please. What does design pattern consist of? There are 3 points to that: intent, motivation, and structure. Intent of the pattern briefly describes what the problem is and how the pattern provides the solution for it. Motivation explains the problem and the solution. The pattern makes it possible. How we are solving the problem just through our clean code. And the structure of the classes show each part of the pattern and how they are related. Many of the patterns consist of many classes and relationships between them that we will see in the following slides. Next slide, please. So design patterns are majorly of three types. They are classified based on their complexity, level of detail, and scale of applicability. There are three types, namely creational patterns, structural patterns, and behavioral patterns. I'll start by creational patterns. So creational pattern provides various object creation mechanisms which increase the flexibility and reuse of existing code. Some of the examples of creational design patterns are factory method, abstract factory method, builder method, singleton method, and prototype. We will go into the depth of singleton and builder patterns of in this presentation. So next slide. Singleton. So yeah, singleton is a creational design pattern that lets you ensure that a class has only one instance throughout your application, and you have to provide a global access to uh, every class of to this instance, right? Many times what happens is in our application, you don't want to create multiple objects of database connections or open file. That creates overhead on the system as well. So what you want to do is you want to ensure there is only single instance of this class and that object has a global access. Anyone who wants to interact with database or that file should have access to that object. But those objects should be controlled by a pattern, which is singleton pattern here. So the structure of the singleton pattern is something like this. There will be a class, let's say it is called singleton here. There will be a private instance and a private constructor. There will only be one public method in this class, which is getInstance, which returns the singleton object. The instructor here is private. That is very important, which ensures that no other class is able to create the object of this class. The object of this class can be called only within this class and in the getInstance method. You can see the instance creation is secured by a null check, which ensures that the instance variable is only initialized once here, once in the beginning, and other subsequent calls of this method getInstance, they return the same old instance created previously. This ensures that we only have one instance created throughout our application. However many classes are calling the class, or it doesn't matter. The application is when your class should have only single instance available to all the clients, such as I mentioned, like a single database object shared by different parts of the program. And you should use the singleton pattern when you need a stricter control over global variables. For example, Spring Framework uses singleton pattern for all the objects defined as beans. That is one real life example. Next. Next is builder pattern. Builder is a creational design pattern that lets you construct complex objects step by step. The pattern allows you to produce different types of representations of a single type of object using the same constructor code. You can imagine a toy factory, right? In a toy factory, there is a conveyor belt, and step by step we shape the toy, add elements to the toy, and at the end of it, we get the final project or final toy. So, for example, there is a image shown here of a house. Let's say we have a house class, but houses are not built equally. Some houses will have garage, some houses will have swimming pool. All of them will have walls and roof. But if we have a type house, we cannot go on and create multiple types of uh, classes, such as house with garage, house with swimming pool, and etc. Even if we want to create multiple constructors for this house, it will be a bit of a hassle because we'll have to create so many constructors with so many parameters, and some of them will have to be optional parameters as well, which is not a very good coding practice, right? The code will be scattered all over the plant code. So the solution to that is builder pattern. And what we want to do, what builder pattern does, it suggests that you extract the object construction code out of its own class and move it to separate classes called builders. Next slide, please. This is the structure of builder pattern. As you can see, I have a builder interface here, which declares product construction steps. And there are two implementations, Concrete Builder 1 and Concrete Builder 2. They describe in detail what each step in the build process is. There is a director class as well, which defines the order in which to call the construction objects. So as you can see in the code snippet, the step A, B, and Z are called sequentially or through conditionally through the code in director. The applications of builder pattern are mainly to get rid of the telescoping constructors, which is, let's say you have a pizza class and you cannot go on and create multiple constructors of pizza class depending on its size, cheese, pepperoni, veggies, with all those parameters, right? You just want to build the pizza incrementally in step by step. And generally, this builder pattern is used in conjunction with composite design pattern. And next slide.
Brinda?
Okay, Brinda.
Yeah. So now we'll go to the behavioral design patterns. These patterns are used to identify communication between objects and implement these patterns. These patterns increase flexibility in carrying out the communication. So Saurabh talked about the how the objects are created using the creational design pattern. Now we'll focus on behavioral design pattern, like how these multiple objects are communicated with each other. Next slide. We'll talk about two design patterns here. First is the state design pattern. In the state design pattern is used when the behavior of an object is altered and its internal state changes. So it appears as if the object is changing its class. So basically, there will be a base class, and these subclasses of this base class will have different states, and it will seem that the object is changing its class like all the subclasses. So these state machines are implemented usually with the conditional statements like if and switch, and there may be nested conditions as well. And based on the appropriate behavior, it will change it to its next state. Next slide, please.
Oh, sorry.
So here's the blueprint of the state design pattern where in the context there will be a state and there will be a method with change state where what it will, based on that method, it will change the next state as required. And others are these, there's a state interface as well, and which will implement the concrete states which it needs to transfer to the next state. And next slide. So this state design pattern is like kind of a finite state machine, where at any given particular moment, there's a finite number of states through which the program can be transferred to. So suppose the state is A currently, and based on some conditions, it will change the state to B. And after B, the next step will be to change it to A. So in this way, it will change this state machine behaves differently at each given time. Next slide. So here we'll take an example of a document class. Suppose we are preparing a document, and initially, like there, it will have total three states. One is draft, moderation, and published state. So initially, it will be in a draft state when we are writing the document, and after that, the user or who has written the document will publish it. So it will be in a moderation state. And now here we'll have two conditions: if it's approved by the admin or if it's rejected by the admin. So if it's approved, it will change its states to published state, and if it's rejected, it will go to the again draft state, and you'll have to modify it again, and then again it will be going to the published state once it's approved. So in this way, based on some conditions, it will change the state. Next slide. Here's the solution where you can create new classes for all the possible states of an object and extract all the behaviors into these classes. So the solution for this document classes the state, which will have render and publish methods, and there will be a draft state in it, and in this way, we can change these states using the if and else conditions. Next slide. So if we talk about a real world analogy of the state design pattern, then in your smartphone, there are many buttons and switches. So whenever you click on the button to unlock the phone, then this leads to various functions. So in here, the states are changed. Then the phone is locked, then pressing any button will lead to unlocking the screen. If the phone's charge is low, then if you click on any button, it will show the charging screen. The next design pattern is chain of responsibility pattern. So this pattern is kind of where you can runs through a chain of handlers. So it will allow you to pass the request from one handler to another. And upon when the handler receives a request, it will have two options: either to pass it to the next handler or process the request by themselves. We'll get the idea of this pattern with an example. That is online ordering system. Suppose we are creating an online ordering system, then the users can order say food with the system. Then there will be an authentication mechanism that if the user is authenticated, then only they'll be allowed. So initially we just have one authentication. Now we also need to authorize the user that authorized users can only order it. Now if the requirement changes, then we also need to provide like a validation that if the proper validations are in place in the input fields, then only will allow. So in this way, many checks will be applied one by one, and all these will be performed sequentially. Like if any one even fails, we can skip that part. So yeah, next slide, please. in this, so to avoid this, there's a solution by implementing the chain of responsibility pattern, where when the request comes in, we can put each handler, one for authorization, one for authentication, one for validation. So if each passes, then only it will go to the next handler. Otherwise, we can stop the request from there itself. So the best part of this pattern is that we can decide not to pass the request further down the chain and stop any further processing. One more example here is about the button in a, website or operating system, where you click on a button, then it will redirect to the next sub panel, and then window. So here the chain of responsibility comes into picture. Here's the blueprint, like how the chain of responsibility is implemented. So there's a handler interface where for each handler, what will be the next handler. So we can set the next handler based on few conditions as well. And if the request is handled by the same handler, then it will process the request. So based on that handler interface, the different base handlers will be created, like as seen in the above, previous example about authentication, authorization. So these all will be the base handlers. And in this way, we can implement the chain of responsibility pattern to process multiple requests sequentially. Next slide.
Yeah, so I'll be explaining some structural design patterns. So the structural design patterns explain how to assemble objects and classes into larger substructures while keeping these structures flexible and efficient. One such pattern is a decorator design pattern, which is very commonly used in the industry as of today. So the decorator pattern allows a user to add new functionality to an existing object without altering its structure. So it is a structural pattern because it is added as a wrapper to an existing class. So when new functionalities need to be added as an application grows, inheritance is not always feasible because it's applied to the entire class. So the decorator pattern is an alternative to subclassing. So subclassing adds behavior at compile time, and the change affects all the instances of the original class. Decorating can provide a better or can provide new behavior at runtime for selected objects alone. So this pattern is designed so that multiple decorators can be stacked on top of each other, each time adding a new functionality to the overridden methods. Because in some object-oriented programming languages, classes cannot be created at runtime, and it is typically not possible to predict at design time what combinations of extensions will we need. So this would mean that new class would have to be created or made for every possible combination of extensions. So let us consider as an example a windowing system. So to add scroll bars to windows, one might want to add a vertical or a horizontal scroll bar. So the first instinct for any developer is to create a subclass called scrolling class and add the scroll property to the window. Now, a new requirement demands to optionally add a border to the window. So now creating another subclass will now be hard because the scrolling class is already changed or created a new type of window class. Hence, we need two more subclasses. So a window with a border and a window with a scrolling bar, also a border. So we finally realize adding multiple classes for a combination of features is not sustainable in the long run. So for the decorator solution, we would have a bordered window decorator and a scrolling window decorator. So now any combination of scrolling window decorator or border window decorator can decorate the existing window structure. If the functionality needs to be added to all the windows, then the base class itself can be modified. So the next pattern that I would like to discuss about is the proxy design pattern. So now it is also a structural design pattern that lets a user to lets us to provide a substitute or a placeholder for another object. A proxy controls the access to the original object, allowing us to perform something either before or after the request goes through the original object. So now, does this sound familiar to or similar to decorator pattern? Yes, but they are different. How? So proxy restricts the client, decorator does not. So proxy may restrict what a client does by controlling the access to functionality, or it may restrict what a client knows by performing certain actions that are invisible and unknown to the client. Decorator does just the opposite. It enhances what its delegate does in a way that is visible to the clients. So now the relationship between the wrapper and the client is what differentiates these two patterns. Decorator empowers and informs its client about what it's doing, but proxy, on the other hand, restricts and disempowers the client. So now let's take an example. Why would we want to restrict who has access to something? As an example, imagine that we have a large item like a database that uses a lot of system resources. We don't always need it, but sometimes we do. We could use lazy initialization, or in other words, in Java terms, it's called auto-wiring, which would allow us to build an object only when one is actually required. Some postpone initialization code would have to be executed by each client of the object. Unfortunately, there would likely be a great deal of code duplication as a result. So the solution to this would be, according to the proxy pattern, one should develop a new proxy that has the same interface as the primary service object. We can then update our app to pass the proxy object to all of the clients of the original object. So the proxy pretty much builds an actual service object and transfers all the responsibility to it after receiving a request from the client. But doing this, how does it benefit anybody? What is the benefits? If we need to execute something either before or after the primary logic of the class, the proxy lets us do this without actually changing the class. Since the proxy implements the same interface as the original class, it can be passed to any client that expects a real service object. So in the above use case, since the item, which is the database, uses a lot of resources, the result could be cached for some time on the proxy. Thereby, we could reduce the latency and the number of calls to the database. The client or the database in this case will not be aware of it. Therefore, it disempowers and encapsulates what is being done from the client and the database. So over to Sayali for the next.
I will be explaining the observer and command pattern. First, let's take a look at the observer design pattern. So observer is a behavioral design pattern which lets you define a subscription mechanism to notify multiple objects about any events that happen to the object they're observing. It is mostly useful when you're interested in the state of an object and want to get notified whenever there is any change. In observer pattern, the object that watch on the state of another pattern are called observer, and the object that is being watched is called the subject. Next slide. Now, why do we need observer pattern? So let's take an example where the two objects are customer and store. Let's say if there is a situation where a customer is interested in a particular object at the store, which is currently out of stock, but then it will be available soon. Then the customer could visit the store every day and check if the product is available or not. But then this will waste a lot of time for customer. Or maybe the store can notify the customer each time a new products come to the store. But then the customer will be annoyed because and also store is also wasting resources on this. So what is the solution to this? Next slide. Now, observable design pattern tries to solve this problem by establishing a publisher-subscriber relationship. Whenever there is an important event happen to the publisher, it goes over to its subscriber and calls the specific notification method on their object. So all the subscriber implement the same interface and that the publisher communicates with them only via the interface. This interface should declare the notification method along with a set of parameters that the publisher can use to pass some contextual data along with the notification. Can you next slide, please? Now let's understand this better by an example. So let's say if you subscribe to a newspaper or a magazine, you are no longer need to go to the store to check if the next issue is available or not. Instead, the publisher sends the new issue directly to your mailbox right after publication or even in the advance. So that way, even the customer's time is saved and even the store does not waste the resources. Next slide, please. Now, what is the application of the observer design pattern? So, observer design pattern can be used when changes to the state of one object may require changing other objects, and the actual set of object is unknown beforehand or changes dynamically. It is mainly used in the reservation system to update the reservation status, or in the flights, maybe in the flight scheduling system where the flight information needs to be updated. Next slide, please. Now let's take a look at the command design pattern. Command design pattern is also a behavioral design pattern. It turns a request into a standalone object that contains all the information about the request. This transformation lets you pass the request as a method argument, delays or queues a request execution, or support undoable operation. Next. So now let's first try to understand the problem. Let's take a scenario where you're building the image editor app as an example. And let's say we are implementing a toolbar in it. So toolbar has a bunch of buttons for various operations of the editor. You create a button class that can be used for button on the toolbar, as well as a generic button in various dialog. So if we create a subclass for each button type, then there will be too many subclasses and it will be very complicated. First, you have an enormous number of subclasses, and that would, but even if that would be okay, but we would be risking breaking the code in the subclasses each time you modify the base class. So your GUI code has now become very complex when it is integrated with the business logic. So when you implement the context menus and shortcuts and add more subclasses, you either duplicate the operation code in many classes or make menus dependent on buttons, which is also complicated. So now what is the solution to this? Next slide, please. So the command design patterns provides a solution on this principle of separation of concerns. So this usually results in breaking an app into layers. For example, there will be a separate layer for the GUI and another layer for the business logic. The command design pattern suggests that GUI object should not send this request directly. Instead, you should extract all the request details, such as object being called, the name of the method, and the list of the arguments in a separate command class with a single method that triggers this request. Command object will be serve as a link between the GUI and the business logic. This will simplify our logic, and this will prevent the uh, complexity. Now let's look at the real world analogy. Let's say we have an interface where there are multiple buttons with multiple payment options, and each payment option will have a different mechanism. Then in that case, we can use the command pattern, which will simplify our complexity, and each interface will implement a separate subclass, and then the method logic will be implemented inside that subclass. Next slide, please. Now let's look at the example. Let's say you're in a restaurant and you are placing an order. The first waiter will come and take your order, and then waiter will give that order to the chef, and then chef will prepare your food. Now here, the order paper will act as a command. It will have all the details of the order, and then chef can just take the order and look at the details and prepare the dish, and then waiter will again take the dish and take it to the server. So this way, the paper will act as a command interface in this. Next slide, please. Application. So command pattern is mainly used when you want to parameterize the object with operation. You can also use command pattern when you want to queue the operation and schedule their execution or execute them remotely. And it is mainly used for building the toolbar for application. That's it. Thank you.